A volcano's shadow? Could Mount St. Helens awaken a giant? This question has intrigued scientists and enthusiasts alike for decades. Volcanoes are powerful reminders of the immense forces at work within our planet. Their eruptions can reshape landscapes and alter climates. They are windows into the fiery heart of the Earth, revealing the dynamic processes that occur beneath our feet. Mount St. Helens and Yellowstone National Park stand as two of the most iconic volcanic systems in the world. Each has its own unique characteristics and history. Both have captured our imaginations with their beauty and power, drawing millions of visitors each year. But what if these two titans of fire were somehow connected? Could their fates be intertwined in ways we have yet to fully understand? Could an eruption at Mount St. Helens, a relatively recent event in geological time, trigger the sleeping giant that lies beneath Yellowstone? This possibility raises many questions. It's a question that has sparked debate and fueled countless what-if scenarios among scientists and researchers. The truth, as with most things in science, is nuanced and complex. There are many factors to consider, from geological formations to tectonic activity. To understand whether Mount St. Helens could truly awaken Yellowstone, we must first delve into the heart of each volcano, exploring their history, their power, and their unique characteristics, and the forces that bind them to the Earth itself. Only then can we begin to unravel the mysteries that lie beneath these majestic giants. Mount St. Helens, a mountain of fire and fury. Located in the Cascade Range of Washington State, Mount St. Helens is a relatively young volcano, a mere 40,000 years old. Don't let its youth fool you though. This mountain is a force to be reckoned with. Its conical shape, once a picture of volcanic symmetry, belies a history of explosive eruptions. Mount St. Helens is part of the Pacific Ring of Fire, a zone of intense volcanic and seismic activity that encircles the Pacific Ocean. This fiery ring marks the boundary where tectonic plates collide, forcing molten rock, known as magma, to rise from the Earth's mantle. Over millennia, this magma has built up, layer upon layer, creating the majestic peaks of the Cascade Range, including Mount St. Helens. The day the mountain blew. Remembering 1980. On May 18, 1980, Mount St. Helens erupted with a fury that shocked the world. The eruption, the deadliest and most economically destructive volcanic event in U.S. history, forever changed the landscape of the Pacific Northwest. The blast, equivalent to the energy of thousands of atomic bombs, ripped away the top 1,300 feet of the mountain, leaving behind a gaping crater. The eruption sent a massive column of ash and gas high into the atmosphere, blanketing nearby towns and cities in a thick layer of gray. Mud flows, triggered by melting snow and ice, raced down the mountain slopes, carrying away everything in their path. The 1980 eruption of Mount St. Helens serves as a stark reminder of the raw power that lies dormant beneath the surface of our planet. Section 4. When volcanoes talk, can one eruption set off another? The idea of one volcano triggering another is not merely the stuff of science fiction. Volcanoes, while seemingly isolated, are interconnected by the vast network of magma chambers and fault lines that lie beneath the Earth's surface. Shifts in pressure and stress along these fault lines can have a ripple effect, potentially influencing volcanic activity over great distances. One example of this phenomenon is the eruption of Mount Pinatubo in the Philippines in 1991. Some scientists believe that this massive eruption, one of the largest of the 20th century, may have been triggered in part by the eruption of Mount St. Helens 11 years earlier. While the exact mechanism of volcanic triggering is still a subject of ongoing research, the interconnectedness of these fiery giants is undeniable. Section 5. A tale of two volcanoes, separated by fate, not fire. These two geological giants, though both awe-inspiring and formidable, have their own unique stories to tell. Now, back to our original question. Can Mount St. Helens trigger Yellowstone? This question has intrigued scientists and the public alike for years. The answer, thankfully, is no. Despite their shared volcanic nature, they operate independently. While these two volcanoes are part of the same restless planet, they are not directly connected in a way that would allow for a chain reaction of eruptions. Their geological processes are distinct and separate. Yellowstone's supervolcano is driven by a different geological process, a massive plume of hot rock rising from deep within the Earth's mantle, known as a mantle plume. This plume is a colossal force, shaping the landscape in profound ways. This plume, a source of immense heat and pressure, is responsible for Yellowstone's geothermal features, its geysers, and its potential for catastrophic eruptions. The geothermal activity is a constant reminder of the power beneath our feet. Mount St. Helens eruptions, while powerful, are not on a scale that could influence the dynamics of the Yellowstone mantle plume. Its eruptions are more localized and less far-reaching. The distance between the two volcanoes, over 700 miles, further reduces the likelihood of any direct interaction. This vast expanse of land acts as a natural barrier, ensuring that the fate of one does not dictate the fate of the other. Section 6. Yellowstone Awakened. A vision of the unimaginable. Yellowstone, a serene and majestic landscape, holds within it a force of nature that is both awe-inspiring and terrifying. While Mount St. Helens poses no immediate threat to Yellowstone, the supervolcano's potential for eruption is a sobering reminder of the forces that shape our planet. The geothermal features we admire today are a testament to the immense power lying beneath. A full-scale eruption at Yellowstone would be a global event, with devastating consequences far beyond the immediate blast zone. The sheer magnitude of such an eruption would alter the course of human history. The eruption would eject massive amounts of ash and gas into the atmosphere, potentially triggering a volcanic winter, a period of prolonged cold and darkness that could disrupt agriculture and cause widespread famine. The skies would darken, temperatures would plummet, and life as we know it would be irrevocably changed. The immediate impact would be catastrophic, with pyroclastic flows, superheated avalanches of gas and ash, incinerating everything in their path. These flows move at incredible speeds, leaving no time for escape. Mud flows, triggered by melting snow and ice, would inundate surrounding areas, reshaping the landscape for hundreds of miles. These flows, laden with debris, would carve new paths through the terrain, altering ecosystems and human settlements alike. The potential consequences of a Yellowstone eruption are a stark reminder of the importance of understanding and respecting the power of our planet. Ongoing geological research is crucial in helping us prepare for and mitigate the impacts of such natural disasters. Section 7. The future of fire. Understanding our restless planet. Volcanoes are a constant reminder that our planet is a dynamic and ever-changing system. While the thought of a volcanic eruption can be frightening, it's important to remember that these events are a natural part of Earth's evolution. Scientists constantly monitor volcanoes around the world, including Mount St. Helens and Yellowstone, looking for signs of unrest. By studying these fiery giants, we gain a deeper understanding of the forces that shape our planet and the delicate balance of life that exists on its surface. So, the next time you see an image of a volcano, don't just see a mountain of fire and fury. See a window into the heart of our planet, a reminder of its awesome power, and a testament to the resilience of life in the face of nature's fury.